Oh, welcome. I'm wondering, how do I solve and graph a one-step linear inequality? This is section 6.1. So first of all, to graph and also to graph a linear inequality, we're going to highlight or shade the set of all points on a number line that represent all solutions of the inequality. A couple things to look at when we're graphing. First of all, if we have the symbol less than or greater than, we use an open circle. If we have a less than or equal to or a greater than or equal to symbol, on our graph we're going to put a circle there at that number and shade it in. That tells us that's part of our solution set. Here are a few examples. Something you could imagine here is that this graph is going to be a pictorial representation of values. You could almost think of this as a thermometer. And you could think of X as the temperatures. So let's say we want all numbers or all temperatures that are less than 5 degrees. So that means our thermometer could be at any number less than 5. So we would do an open dot at 5. So that tick mark is just showing that it's at 5. Like here's our number line, right? So there's a tick at 6, a tick at 5, a tick at 4. But we have an open dot. I can clearly see some white in there, and that tells me that 5 is not part of my solution because 5 is not less than 5. What is less than 5? 4 is, 3 is, 2 is, 1 is, 0 is, negative 1, negative 2, negative 3. All those values are less than, and so is any number just barely left of 5. 4.99999 is less than 5. And then I put an arrow showing that it goes forever and ever. So here's the expression. I read it all real numbers less than 5. My solution is less than 5. And then I shade that region. All real, So you might want to look at the expression first because this is what we'll be practicing. So this would say that all numbers greater than negative 3. So on our graph, we're going to start at negative 3. Of course, we'd have negative 2 to the right and negative 4 to the left on our number line. We want numbers that are greater than negative 3. So numbers to the right are greater. Think of negative 3 as owing someone $3. That stinks. I'd rather owe someone $2 than $3. Or negative 1, I'd rather owe them $1 than $3. Or 0, I'd rather owe them nothing than negative $3. Of course, owing someone negative $8, that would stink too, right? So at least you're not there. It's greater to owe less money or not owe money. Here's a good question. What temperatures cancel school? Oops, just kidding. You wish. Back in elementary school, for what temps can you not go out for recess? Well, at least when I was growing up, it was any temperature that was less than or equal to 0. So on our number line, even if it was 0, we couldn't go out. So 0 is now part of the solution set, meaning values that won't allow us to go out. Anything at 0, and that's why I filled it in, because 0 is part of the solution set. Anything at 0 and less means we can't go out. Here we want all numbers that are greater than or equal to negative 2. Well, negative 2 is equal to negative 2, so I'm going to fill it in. Again, that's a closed dot. That's part of my solution. Then I'm going to shade all numbers that are greater than negative 2. And that would be to the right here because negative 1 is greater than negative 2. 0 is greater than negative 2. And all positive numbers are greater than a negative. So that's reading expressions, graphing expressions. Now let's work on solving expressions. So solving a linear inequality is like solving a linear equation, except for now our equal sign is going to look like a Pac-Man symbol. Your goal is to isolate the variable on one side by using transformations that produce equivalent inequalities. So again, what we do to one side, we have to do the other side, and our goal is to get the variable by itself. But there's something that we need to realize here. When multiplying or dividing by a negative, you have to switch the inequality sign. You have to switch the direction of it. Maybe we should throw that in there. We have to switch the direction. So here we go. This says negative x divided by 3 is less than or equal to 8. So how do we undo dividing by 3? That's right, we would multiply by 3. But we also have to undo this negative here. So that's, instead of multiplying by 3, let's multiply by negative 3. Because a negative divided by, a negative times a negative is a positive. Well, so is a negative divided by a negative. And what we do to one side, we have to do to the other. So, negative 3 divided by negative 3 is 1. So we're left with x. So we have x is less than or equal to negative 24. There is our solution. And we could graph it, but right now let's just practice solving the inequalities. There we are. Just repeated that intentionally. So there's this rule though, right? What did I do to each side of the inequality? We multiplied by a 3, but not just a 3, it was a negative 3. So here's what I mean by switching the direction of the inequality symbol. Pac-Man, or the inequality, is facing right. Well, now we need to switch it. It needs to face left. So our solution now says that x is greater than negative 24. Now, if you took a number that was greater than negative 24, like negative 20 or 0 or 100, and you checked any one of those things that we think are the solution, if you check any one of those numbers, it would make this original inequality true. If we wouldn't have switched the sign, what I had boxed earlier, those were wrong. And if you would have tried any of those incorrect solutions in here, it would not make this inequality true. Alrighty, rock and roll, here we go. Let's try this one. What's being done to x? It's being multiplied by a negative 2/3. So to undo that, we'll multiply by the reciprocal. We'll multiply by negative 3/2. So multiplying by the reciprocal undoes itself. And so we have x. On the right, we have 4 times negative 3, which is negative 12, divided by, well, on the bottom of this 4 is a 1. 1 times 2 is 2. Now I multiplied by a negative, so I need to flip the direction of the Pac-Man. So instead of eating to the right, Pac-Man will eat to the left in this case. And then I could simplify this to x is greater than negative 6. And again, if you plug in, say the number 0, because 0 is greater than negative 6, you get that 0 times negative 2/3 is 0, and 0 is truly less than 4. Once you do that the simplifying right there, the mathematics behind it. So yeah, I'm totally believing this flipping the direction, only have to multiply by a negative. And it's only when we multiply or divide by a negative. Here, x is being multiplied by negative 4, so we'll divide by negative 4. So we get x is less than or equal to. So here the Pac-Man was eating to the left. We multiplied, or in this case we actually divided by a negative, so we have to switch the symbol. There's our solution. Now it's only when we multiply or divide by a negative. If we add or subtract a negative, it doesn't flip it. If we add or subtract a positive, it doesn't flip the direction of the symbol or the inequality. And if we multiply or divide by a positive, it does not switch the direction of the inequality. So I gave you 3 examples. All of these had flipping, but that's because we were multiplying or dividing by a negative. Now also something to think about, when x is on the right side of the inequality, we should put the x on the left side of the inequality when we get done. But then we have to switch the Pac-Man as well. I'll show you what that looks like. So here, x is on the right. It's being subtracted by 3. So how do we undo subtracting by 3? Add 3. So we get 7. Now we have no reason to flip this inequality. Just because I showed you 3 that did, we're not multiplying or dividing by a negative here, so please do not flip that. And then we bring down the x. So this says 7 is less than x, or x is greater than 7. Both are true. That's our kind of our answer. However, oftentimes it's polite to have your variable on the left. So that means that x would be on the left and 7 would be on the right. But this says that x is greater than 7. So we need to write that. Pac-Man's eating the x. Pac-Man needs to keep on eating the x. So when you flip the side of the inequality that x is on, you also have to flip the inequality. That keeps it reading the same way or meaning the same thing that you had calculated. Here, x is on the right. And actually, so x is, what's being done to x? Nothing, it's all by itself. So x is less than negative 12. That's the answer. Well, let's put x on the left, negative 12 on the right. And again, the inequality is eating the negative 12. So we need to keep it that way, which means we need to flip the direction of the symbol. Last but not least, here x is on the right side of the inequality. It's being added to by 16, so we'll subtract 16. Now I'm taking away 16, it's a negative, but I'm not multiplying or dividing by a negative. So I will not, when I bring down my simplified inequality here, I'm not going to flip the direction of the inequality. I'm just going to bring it straight down. So the answer says that x is less than or equal to negative 20. Or negative 20 is greater than or equal to x. But let's put the x on the left side instead. So we switch the x in the value, but then we also have to switch the direction. The inequality is eating the negative 20, so it needs to keep on eating the negative 20.